Good afternoon, kiddos. Here we go on section 8.2, similar polygons. If you will take a minute and make sure your table of contents is up to date, then you will be more likely to get full credit when we have our notebook grade. So please make sure that you have updated your table of contents. Today's objectives are to use similarity statements to determine if two polygons are similar and to find corresponding side lengths in similar polygons. So let's get this party started. There's some Desmos investigations that we will look at in class together, and so I'm going to bypass these slides. The links I will put in your Canvas page if you want to explore them on your own. All right, so similar figures. Similar figures have the same shape. So if you think about a triangle, the three angles sum 180. And if I enlarge that triangle or reduce that triangle in size, the three angles still add up to 180. So the angle measures aren't changing, but what happens is they have a different size. Now, the symbol for similarity looks like this right here. It is just the squiggly that's on top of the congruent sign. So we're going to drop the equal sign and just use the squiggly part. So from here on out, when you see the word is similar to, you can use the little. All right, so in the diagram below, if you look, triangle A, B, C is similar to triangle D, E, F. And if you look at your pictures and you notice angle A here has one hash in it, angle D here has one hash in it. If you look at B and E, they have two hashes, and C and F has three hashes. So what happens in a similarity transformation is we preserve the angle measure, which means the corresponding angles are going to be congruent. Now, what is scale factor? Scale factor is the ratio of the corresponding sides. You do need to be cautious of whether you're looking at an enlargement or whether you're looking at a reduction, and we will talk more about that on a future slide. So in a similarity transformation, it enlarges or reduces the side length by a scale factor of k. So corresponding side lengths are going to be proportional. So if you look at the pictures above, here we have B, and here we multiplied B by K. Here we have A, here we multiplied A by K. So going from the figure to the left to the figure on the right, we have an enlargement because we're multiplying, well, if K is bigger than 1, it's an enlargement. And then if K is between 0 and 1, it's going to be a reduction. So if you think about what I just said, if K is between 0 and 1, you have a reduction. And if K is greater than 1, you have an enlargement. And if you think about it, if K equals 1, you're actually going to have a picture that's the same size. So that's when we drew those inequality symbols, we did not put the is equal to part with that. All right, so when we think about corresponding angles, we kind of talked about this on the last slide. You do not have this in your notes, I do not think. So if we think about the corresponding angles, what happens right here is look at the number of hashes. So angle A corresponds with angle D. So angle A and angle D are corresponding, and actually they're going to be congruent because they're similar figures. So angle B, and you do not need to be writing this down, just kind of watch and listen. Angle B is going to be congruent to angle E, and then angle C has 3 hashes, and over here angle F has 3 hashes. So those are all congruent angles, which is a sign that figures are similar. So then the ratio of the corresponding lengths is going to be the scale factor. So if I take the figure on the right, which is KA, and I put it over A, that's going to equal KB over B, which is going to be KC over C. So in this particular figure, our scale factor is K. So let's see what's going on. Here's an example that is also not in your notes. So I just literally want you to put your pencils down and just kind of process what is going on here. So when I look at what's going on, when I look at the bottom triangle that has all 3 sides, I have a small number, I have the medium number, and I have the large number. So when I look over here, 15 is definitely my smallest number, and X is my hypotenuse, so I know that it's going to go with 30. If I have to pick 15 and 18 or 15 and 24, I look, 15 and 18 are my smallest two sides, so I'm going to put 15 over 18. Here I have 20 and 24. You will know if these are similar in the end if all three sides are proportional. So if I think of numbers that go into 15 and 18, these are all divisible by 3. 15 divided by 3 is 5, and 18 divided by 3 is 6, so you get 5/6. If I take 20 over 24, these are both divisible by 4. 20 divided by 4 is 5. 24 divided by 4 is 6. So since these both have the same proportion, I know that when I take and I put x over 30, that these are going to have to be equal. From here, you can cross multiply. Because you know I don't love you using the calculator. If you will not actually multiply the numbers together, you're making a number bigger and bigger and bigger, and then you're going to have to deal with it. If you'll just write it 30 times 5, when you come in here and you divide by 6, you have a pretty easy reduction now, because I know that if I look here, 6 and 30 reduce to 5 over 1, because 6 goes into 35 times and 6 goes into itself one time. So now I have 5 times 5, which is 25, and that tells me that x equals 25. If I come up here and I set up that proportion and I take 25 over 30, both of these numbers are divisible by 5. 25 divided by 5 is 5, and 30 divided by 5 is 6. So we can tell that all three sides reduce down to the same proportion, so that is very helpful. I really do want you guys to practice this right here of like not multiplying to get really big numbers. What all we're going to do in a minute is break them back down. You can do the multiplication much faster, and you can do it without a calculator if you will practice that skill. All right, so now let's go back to your notes and let's look at example 1. I know some of these numbers are hard to read on your examples, so if you need to hit pause at any time and write the numbers on your paper, please feel free to do that. So in the diagram, we have triangle GHM, and remember that this symbol means similar, so similar to triangle HKL. So now when I look at my bottom triangle, I have 10, 12, and 18 are my small, medium, and large. So when I look at my big triangle, that's going to correspond here, small, medium, and large. It does not matter. You could put 15 over 10, or I could come in here and put 12 over 87. If I put 15 over 10 and I put 27 over 18 and I reduce those, these numbers are both divisible by 5. 5 goes into 15 3 times, 5 goes into 10 twice. 27 over 18, both of those are divisible by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So it doesn't matter which of those ratios I use to start my proportion, but I'm just going to reduce it since I've already reduced it. And I'm going to use 3 over 2. And then I'm going to pull the x and the 12. Since I use 15 in my numerator, I have to use x in my numerator, which means 12 will go in my denominator. So you get 3 times 12 equals 2x. If you divide by 2, if I think about canceling, 2 and 12 reduce to 6 and 1. So 3 times 6 is 18, and that's going to be the value of x. You can check that, because if you take and put 18 over 12, both of these numbers are divisible by 6. 18 divided by 6 is 3, and 12 divided by 6 is 2. So it definitely fits the pattern. All right, example number 2. So if we look at example number 2, we actually have a quadrilateral this time. If I look at my quadrilaterals, I have x and 4 here. So x is side BC, which means it's going to be corresponding to RS. So if I just want to start out by putting x over 4, I can. It does not matter which pair of other sides you use, just be consistent. I put this figure in my numerator, which means this figure here has to go in my denominator. So you can pick a set of numbers. I think I'll pick 12 and 6, so this equals 12 over 6. I see this as two options. You can multiply 12 times 4 equals 6x, or sometimes I think it's way helpful to go ahead and reduce this to 2 over 1, because now you're using smaller numbers. Either way you go, here if you cross multiply, you get x equals 8. Here you would divide by 6. And if we do some quick reducing, 6 goes into itself once, 6 goes into 12 twice. 2 times 4 is 8, so x equals 8. So you're getting to a point with your math that you have lots of different paths you can take and still get the correct answer. Just watch that reducing, and I'm going to encourage you not to be using a calculator and just build your number sense. All right, example 3. Find the scale factor from RST to triangle XYZ. So this is a reduction, which means we need to put the smaller triangle over the larger triangle. So in order to get the correct scale factor, you're going to put the smaller triangle over the larger triangle. So if we look at figure A and we do corresponding sides, looking here, side RS corresponds to XZ, so RS and XZ, so I'm going to put 12 over 20. And then I have ST and XY. So if I come here, I have ST, and I said XY, I meant, yeah, I have RS is going to correspond to XY. RST. I've already done RS and XY, so let me move on. Sorry, I just had a major brain fart. ST and YZ. So here's ST and here's YZ. So I'm going to do 18 over 30. And then last but not least, I'm going to have RT and I'm going to have XZ. So if you have RT, you have XZ, which means you're going to have 15 over 25. So I want you to take a minute. I want you to reduce all 3 of those fractions, and let's just confirm that scale factor. All right, welcome back to us. If you divided both of these by 4, you ended up with 3 over 5. Divided both of these by 6, you ended up with 3 over 5. And divided both of these by 5, you ended up with 3 over 5. So I think it is safe to say that our scale factor is going to be 3 over 5. Which shows a reduction. So if you started with the figure on the left here and went to the figure on the right here, you're actually reducing this in size. All right, if we go through and we list all the congruent angles, you know me, I'm a big advocate in using your similarity statement or the order of your letters that you're originally given because I think you make less mistakes. So angles, here you have angle R because it's the first letter, and angle X. So angle R. And remember, these are congruent angles. So in similar figures, the angles are congruent, the sides are proportional. Your second letter is S here, your second letter is Y here, so you're going to have angle S is congruent to angle Y. And last but not least, we have angle T is congruent to angle Z. All right. And last but not least, they want a statement of proportionality. So a statement of proportionality says that we are going to write the ratios of the congruent or the proportional sides. So we are going to take, and since this is a reduction, we're going to start with the figure on the right, and we're going to have side XY, and it corresponds to side RS. Remember, you can always come up here to your statement here. If you use these 2 letters ST, it's going to go with YZ. So you could come over here and say that YZ is going to go with ST. And last but not least, what did we forget? ZX over TR. Okay, beautiful. Moving on to the next example. It says, find the value of X and state the scale factor of the polygons. So triangle WLJ is similar to triangle QBV. So if we look at this and use this as our example, then we can come in and we'll say that I'm going to start with the triangle on the right, and that way, and I'm just going to use this as an enlargement. The biggest thing here for solving for X is that you're consistent. If you put 8 over X plus 6, this is going to equal 5 over X. I'm going to highly encourage anytime you have a binomial that you put that in parentheses, so when you cross multiply, you remember to distribute. So if I take 5 times X plus 6 equals 8X. I distribute my 5x plus 30 equals 8x. And now when I finish my math on this one, I end up with 3x equals 30 and x equals 10. All right, so now that I have solved for x, you can go in and you can do the scale factor on this one. So when I look at this and have to decide my scale factor, I'm going to take and just substitute in x. So if I take 5 over 8, my scale factor is going to be 5/8. So if you look from here to here, you're actually getting smaller. So that is going to be a reduction. So your scale factor is going to be 5/8. Last but not least, example 5. Again, if you need to write this on your sheet because you can't read it, please feel free to do so. Okay, I definitely need to find x. So x is right here, and this is kn. So when I look at this, this is kn. So if I'm going to put kn over a side, it has to be rp, which would mean it's going to be this side right here. When you're setting up your proportion just to solve for a variable, it doesn't matter which figure goes in your numerator. It does matter for your scale factor. Okay, so just be consistent when you set up your proportions unless you're doing your scale factor, and then you have to decide reducing or enlarging and which figure goes where. I will put the figure on the left, 3x minus 2, over the figure on the right, which means I'm going to have to pick the figure on the left and put it over a corresponding number on the right. Of course, I boxed in the decimals. I do not want to use decimals, so I think I would rather use 4 and 3. So over here, I'm going to put 4 and 3. So 4 and 3, x minus 2 are both on the same quadrilateral, so that's why they're both in the numerator. Remember, the other smart thing to do, go ahead and put that grouping symbol. Use those parentheses. All right, take a minute, hit pause, come back to me when you're done, and we will check your work. All right, so if you hit pause and you did your work, you should find that x equals 22 over 5. You know me, love those fractions. Do not convert them to improper fractions or to decimals. All right, we will work on homework tomorrow in class, and if you have any questions, I will be more than happy to answer them via a Canvas message, or you can ask them when you come to class tomorrow. Have a great day.